So this is something that we're going to need later on in the calculus course. After I explain to you what a derivative is, and when we're calculating eventually the derivative of sine theta, I'm going to use this. And as is often the case, you're going to see that a lot of calculus concepts really go back to learning our trig really well. So what I want to show to you now is that if I take sine theta divided by theta, then this is going to be, first of all, less than 1, and second of all, bigger than cosine theta. And this is always going to be true, at least if angle theta is bigger than 0 and less than 90 degrees, or if we're in radians, and we like to use radians in calculus, the 90 degrees is going to be pi over 2. So how can I show this? The first time I saw this, this looked really funny to me. Actually, not just funny, a little bit frustrating. I didn't know how to prove it. Try as I might, but then I learned this really neat argument that has to do with areas of triangles. So let me show you how to get there. We're going to use everything that we've talked about so far. We're going to use the unit circle. I guess it looks a little bit elliptical, but that's supposed to be the unit circle. Bear with me. Say we've got some angle theta. And say this is unit circle, so the distance from 0 to this point is equal to 1. And I'm going to make a couple different triangles. So first of all, I'm going to take the point here. This is x equals 1, y equals 0. And I'm going to make a straight vertical line. And I'm going to wait until this line intersects this line segment coming out at angle theta. So that's one triangle. The next one I'm going to make goes from this point, x equals 0, x equals 1, y equals 0, all the way up to whatever that point is, giving me this triangle here. And there's one other thing I'm going to consider. I'm going to consider the pizza slice that has angle theta and then comes out like that. And actually, to illustrate the difference, let's bring some color into our lives. Let's use red for the smaller triangle. Let's use yellow for the pizza slice. And let's use blue for the largest triangle. Hope that's not too busy. But you can definitely see from the picture that the Dorito is smaller area than the pizza slice. And then both of those have a smaller area than the blue triangle. Okay, and so what I want to do is find all those areas. So first of all, I want to find the area of the triangle in red. And the way I want to do that, I want to use this formula that it's going to be 1/2 times A times B times sine theta. And so I need two side lengths and an angle between them. And so which two side lengths do I want to pick? Well, here this side length is equal to 1 because it's unit circle. This side length is also equal to 1 because it's unit circle. And so when I plug that in, I'm going to get 1/2 times 1 times 1 times sine theta. And so that's just going to give me sine theta over 2. And now that I've got that calculation, let me erase it and just collect it up here. Next, I want to find the area of the pizza slice. And for this one, well, I have to know the formula. And you may remember that the area of a circle is pi r squared. And I can rewrite this as, if I want, as 2 pi over 2 times r squared. And so why did I do that? Because if you want the area of a pizza slice, what you have to do is you have to look at how much pizza you've got. So you've got to look at how big this angle is. If that angle is equal to 2 pi, then you want to get pi r squared. So that's theta equals 2 pi divided by 2 times radius squared. So this formula is actually theta over 2 times r squared. But if theta is not equal to 2 pi, if theta is smaller, then this is the general formula. And here our radius is equal to 1. So this area is nothing but theta over 2. That's the trick. That's how I'm going to compare theta to sine theta. But I need one more thing. I need to figure out what's the area of this big blue triangle. And this one I can do with this same method, a times b times sine theta, except the problem is that I'd have to make this length. I could also do half of base times height, which would be 1/2 times height. And that's actually what I want to do. So in order to do that, I need to know what's going to be this height. And how can I figure that out? Well, given angle theta, let me remember. I was looking for my eraser. It's right here in my hand. So let me remember that tangent of theta is equal to what? The opposite side divided by the adjacent side. And here my adjacent side is equal to 1. So opposite side divided by 1, that's just the length of the opposite side. So here's the length of the opposite side, and I know that has to be tangent of theta. So I can just go ahead and plug that in. Whatever theta is equal to, its tangent is going to be the length of that opposite side. This is actually why tangent is named what it is, because later on we'll learn that this vertical line is tangent to the circle at that point. And so its length is given by the tangent of theta. Anyway, the area of the blue triangle, now that's going to be nothing but half of base times height, so that's half of 1 times height. That's tangent theta. So knowing that the red area is less than the yellow area, is less than the blue area, gives me some inequalities. So it tells me that sine theta over 2 is definitely less than theta over 2 is definitely less than 1/2 tangent theta. And in the beginning, I said this works as long as theta is between 0 and 90 degrees. And as long as that's true, then our picture is accurate. Otherwise, we might have to do something else. So how do we go from here to where we want to go? Well, let's focus on, this is really two different inequalities. Let's focus on this one first. So starting with sine theta over 2 is less than theta over 2. I can multiply both sides by 2 and get sine theta is less than theta. Divide by theta, and you get that sine theta over theta is less than 1. So that's part of what I wanted to show. I also wanted to show that it's bigger than cosine theta. And how can I do that? I'm now going to work with this inequality. So I'm now going to work with theta over 2, which I know to be less than tangent theta over 2. Let me erase this for the moment. Keep on working. So I can divide or multiply both sides by 2. And tangent theta, now I have to remember that tangent theta is sine theta over cosine theta. It's also opposite over adjacent. And if you expand this out to opposite over hypotenuse divided by adjacent over hypotenuse, then you'll see a cancellation and you'll get that formula. But another way of thinking of tangent is just sine theta over cosine theta. And once you do this, you might get an idea. I want to get something involving sine theta over theta. So you might first multiply by cosine and then divide by theta. And when you do that, you'll get cosine theta because you multiplied both sides and canceled that out. And sine theta stays where it is, and then divide by theta. And there you go. Just a small note about this. You can multiply both sides of an equality so long as the thing that you're multiplying by is positive. And as long as theta is between 0 and pi over 2, then sine theta and cosine theta are both going to be positive. So it's valid to multiply the inequality like that. That's another reason we needed that condition. But now I've shown that cosine theta is less than sine theta over theta. And I knew from before that this is less than 1.